All right, guys, second part of the video. Students tell me they prefer videos at around 15 to 20 minutes. Some people don't care. They just stop it and go do what they want to do and then come back. So, I'm trying to work more on creating shorter videos. So anyway, let's work the rest of these. Number 6, the average outstanding bills for delinquent customer accounts for a national department store chain is normally distributed with mean 187.5, standard deviation 5.40. In a random sample of 50 delinquent accounts, what is the probability that the mean outstanding bill is over $200? So guys, here we have to find the mean of the sampling distribution. So that's going to be the mean that's stated for the entire population. And we got to find the standard error. Well, the standard error is 5450 over the square root of the sample size, which in this case is 200. Now we can go ahead and round that out. So if I take 54.5 divided by the square root of 200, I want to take it out to about 5 places for technical accuracy. 3.85373. All right. So now what we want the probability is over 200. So I guess we have a normal distribution problem. So mean 187.5. Standard deviation 3.85373. And we want greater than, oh guys, I messed up. Shoot. The probability sample size is 50. I would tell you it's the first mistake I've ever made, but I don't think you would believe that. So I can't believe I did that. Oh well, everybody's entitled to a mistake, right? Especially if you catch it. So guys, this should be 7.70746. Much better. Raise your hand if you notice that. Obviously, I can't see you, but I'm sure a lot of people are raising their hand. So 7.70746. Guys, sorry for that. And greater than 200. So 200 is the amount of the outstanding bill, not, obviously you can't have $200 of people. That's kind of ridiculous. So anyway, compute, and you can see that our area to the right is 0.0524. All right, gang, get into some matching of notation. So the Greek letter mu, that's the population mean, so that should be pretty easy. Sigma is the population standard deviation. N is your sample size. X bar is the sample mean. S is the sample standard deviation. P is the population proportion. Sigma sub x bar is the standard error for the distribution of sample means. U sub x bar is the mean of the distribution of sample means. And p hat is the sample proportion. Now, anytime you see a sigma, well, in this case, E is the population proportion, these things I am circling are called parameters. So again, anything that comes from a population is called a parameter. These things that I'm boxing in, that represent samples, these things are called statistic. So if our measurement comes from a sample, it's called a statistic. If it comes from a population, it's called a parameter. I'm pretty sure there's a problem like that on your homework assignment. In your own words, describe the difference between mu and mu sub x bar. Well, guys, mu is the population mean. And mu sub x bar is the population mean of the distribution of sample means. Hence that sub x bar right there, sample means. So mu, population mean, sub x bar goes to the distribution of sample means. Number 9, a USA Today Lifeline column reported that in a survey of 500 people, 39% said they watched their bread. I have no idea where this problem comes from. While it's being toasted. Find the margin of error for a 90% confidence interval for the percentage of people who watch their bread being toasted. Guys, I'm usually so busy I don't have time to just stand there and watch my bread being toasted anyway. So guys, p hat's a little weird to find here. Okay, so p hat, remember, is x over n. And when we work these problems, let's go over. Let me show you what's going on here. When I go to stat and go to prop stat, go to one sample with summary, what I need is I need my number of successes, which is my x, and my number of observations, which is my n. The way this problem is given, I'm given the percentage of the 500 people. So I'm given the p hat, which is 0.39. I'm not given the x, and I'm given the n of 500. Well, guys, I can easily solve x by multiplying 0.39 times 500 to get 195. Now, if I go do something goofy and try to put like number of success over here and use something like 0.39, I'm going to get something goofy. Number of successes means it's a count. Number of observations means it's a count. So I have to do this calculation to get the count before I can actually use StatCrunch to create my confidence interval. Now, ultimately, guys, I want the margin of error, but I got to get the confidence interval to create the margin of error. Okay? So, guys, I'm going to put 195 there. I'm going to put 500 right there. And I want to change my confidence level to 0.90. So guys, my upper limit is 0.426. My lower limit is 0.354. So guys, remember the margin of error. One of the easiest ways to find that is the big number minus the small number over 2. Now we add a plus and a minus to that. So I'm going to take 0.426 minus 0.354. Guys, make sure you put the values in the numerator in parentheses. Divide by 2. So we get plus or minus 0.036. And I like to think of this as plus or minus 3.6%. All right, number 10, some of the research reported recently indicates that the proportion of adult women in the United States is 51%. I don't know what that means. So I guess of all the adults, 51% are women? I guess, okay. So a marketing survey is sent to 350 adults. What is the probability that less than 55% are adult women? So guys, I need the mu for my p hat, which is the 0.51. I need the sigma for the p hat, which is the square root of 0.51 times 0.49 over my sample size, which is 350. So guys, I'm going to put this in my calculator and round out to a whole lot of digits so for technical accuracy. So I get 0.02671, let's call it. All right, so that's the way I did it. All right, so we want probability less than 55%. So gang, this could be an easy problem. We model this with the normal distribution. So our mean is 0.51. Our standard deviation is 0.026721, and we want less than 0.55. Now notice I can use the 0.55 here, the proportion, because my parameter, 0.51, is as a proportion. So I can find the probability of a proportion when my mean and standard error are given as a proportion. But I can't put the count in there unless my mean and standard deviation are given in terms of count. And there's a way to work problems that way. I think it's harder, and I don't teach it that way, but there actually is a way to do that. So guys, the probability would be 0.9328. All right, gang, we are getting close. I have a meeting in 12 minutes, so I need to wrap this up pretty quickly. How does changing the following quantities affect the width of a confidence interval for a population mean? Now, guys, remember the formula for a population mean, if the population standard deviation is given, or it's x bar plus or minus t star over the standard deviation over the square root of n if the population standard deviation isn't given. Nevertheless, the width is completely determined by what we add and subtract to the sample mean, the point estimate. So decreasing the confidence level from 95% to 90%, this value would decrease in both cases, which means the width would do what? What would happen? So we're going from 95% to 90%. So if you remember back when I did the z's, just for example, of the confidence intervals, we looked at 90, 95, 99. This was 1.96. This was 2.58. And this was 1.28, right? So this value is going to decrease, which means that the width would decrease. All right, decreasing the sample size from 100 to 50. If we put a 100 there and change it to a 50, this value is going to decrease, which makes the total fraction increase, which means that our width will increase. Think about it. Take a bigger number and decrease it. A bigger number and decrease it. This fraction's bigger, causing an increase. Decreasing the standard deviation from 10 to 5. If I take this as a 10 and move it to a 5, I decrease this value. Hence, I'm going to decrease the margin of, the width of the confidence interval. And the width is just the margin of error. All right, gang, final question. ACT scores are normally distributed with mean 18.7, standard deviation 5.9 to find the mean and standard deviation of the sampling of the distribution of sample means when n is equal to 50. Actually, we should say not the standard deviation, but the standard error. Okay, now the standard deviation, the standard error is the standard deviation of the distribution of sample means. So guys, ultimately we're asking, what is mu sub x bar? And what's sigma sub x bar? Well guys, mu sub x bar is the population mean. That's an easy one. And sigma sub x bar is the population standard deviation over the square root of the sample size. So if you were putting this in as a decimal, I'll just go ahead and do that. It would be 0.834, let's call it. All right, not really worried about consistency of the way I round, because you round according to the number of digits that my stat lab request. All right, gang, I hope this helps. It's either going to help by giving you another opportunity to look at some of these problems. If it doesn't help, hey, chalk it up to an easy homework score. You just get, if you already have all this stuff mastered, it's a week to kind of step back and take a deep breath, plug in the answers, get a high score on this assignment, and then get prepared for the next branch of stuff. Next thing we'll look at next week will be hypothesis testing for means. So, guys, I hope you're having a great week. And again, I hope this helps. And I guess time will tell when I look at your final exams if the scores on these types of questions goes up from previous classes. Then this has been a good way to spend our time this week. All right, guys, got to go.